People don't usually think about the land they're standing on as moving. To most of us, the ground seems steadfast, solid and permanent, an unyielding platform for our homes, roads, and forests. But the truth, as it turns out, is far stranger.
In western Washington, thousands of people living near rivers have been told to find higher ground.
The flooding in that region is being described tonight as catastrophic and historic.
But the truth, as it turns out, is far stranger. Massive continents drift. Mountains rise and erode over eons. In more subtle ways, too, Earth's surface can quietly shift and change, often hidden from sight or happening so gradually that only the most watchful eyes even begin to notice. Yet beneath our feet, the Earth is never truly still. Its restless heart beats with a rhythm that's impossible to sense day to day, but becomes undeniable when viewed across centuries. To stand on the soil of Washington and feel stability is an illusion, one that is challenged not just by history, but by science. Unfolding beneath us is a story of pressure and release, a saga of ice, magma, and stone, layered with secrets written slowly over geologic time. But what if we had eyes in the sky, watching every square mile, all the time, with uncanny sensitivity? Enter NASA's satellite fleet, a silent, vigilant network that reveals the unseen rhythms beneath our feet. In recent years, these satellites have recorded something remarkable across Washington state. The ground itself is slowly, almost imperceptibly, lifting. A rise that's too gentle to make headlines, too slow to sense in a single day, and yet deeply significant. What is causing this mysterious uplift? What secrets about the past and the future does it hold? And how is NASA's ever-watchful technology uncovering these invisible movements right under our noses? Let's dig down, sometimes literally, and unravel the dramatic story of a landscape that refuses to stay still. Chapter 1. NASA satellites map Earth's movements. Satellites are among the most ambitious creations of the modern world. Thousands of machines spinning overhead, busy with tasks from relaying phone calls to peering into the distant universe. But perhaps one of their most unusual jobs is to survey the ground we live on with breathtaking sensitivity. NASA's Earth-observing satellites can pinpoint movements as tiny as a few millimeters using a technology called INSAR. With INSAR, satellites bounce radar signals off the ground and, on each orbit, compare them to previous readings. When the surface moves, whether it's from a creeping glacier, a shifting fault, or a swelling hill, the pattern of reflections subtly changes. The satellites stitch these changes together, frame by frame, creating time-lapse movies of the Earth's surface. In Washington state, this eye-in-the-sky technology has revealed something that's as subtle as it is puzzling. The land is gradually lifting up, its reasons hidden below layers of forest, rock, and soil. What could be pushing an entire region upward, almost in slow motion? Imagine the complexity involved in distinguishing small changes among forests, cities, mountains, and wetlands. A mosaic of environments, each with their own quirks. The precision needed to detect ground tilt or uplift is mind-bending. Satellites must see through cloud cover, contend with interference from weather and vegetation, and account for countless variables on Earth's surface. Yet their focused radar beams ignore distractions, measuring the swelling and subsiding of land features invisible to even the sharpest human observer. With every pass, these satellites quietly chronicle the restless heart of Washington itself. Chapter 2. Washington, a volatile landscape. Washington state is a tapestry of drama. Not only does it host bustling cities and staggering forests, but it also sits within one of North America's most geologically restless regions. Between the Pacific Ocean and the jagged Cascade Range, the land bears the scars and marks of a dynamic planet. Ancient volcanoes, earthquake-prone faults, and rivers that slice deep valleys all speak to a landscape shaped and reshaped by restless energy. This is a region carved by the elements and molded by forces so ancient their footprints are visible across breathtaking vistas. The Olympic Peninsula, battered by rain and wind, rises sharply from tidal shorelines, while the Cascade volcanoes dominate the skyline with snowy, cloud-wreathed summits. Nature's artistry here is as dangerous as it is beautiful. As plates grind and slip far below, rivers like the Columbia and the snake through valleys excavated by glaciers and landslides. Within this setting, even quiet, nearly invisible movements of the ground carry extra weight. Here, the Pacific tectonic plate grinds relentlessly beneath the North American plate. A collision that has raised mountains, built volcanoes, and, according to new satellite data, is now causing the ground itself to rise in ways not visible without NASA's distinctive view from space. Could these subtle shifts hint at something brewing deep below? Or are they the after effect of ancient planetary forces that never truly go quiet? Chapter 3. Revealing Uplift, Dr. Ashley Richards. To pierce the fog of mystery surrounding Washington's silent rise, scientists lean hard on data, and on experts like Dr. Ashley Richards, a geophysicist immersed in the minutiae of Earth's slow dance. Using satellite snapshots spaced days, weeks, or months apart, Dr. Richards and her team can map out where and how quickly Washington's ground is lifting. It's a painstaking process. Thousands of square miles of forests, farms, and ridges are translated into vivid, color-coded maps, each hue representing a different velocity of vertical movement. On any given chart, a vast region might show faint shades of uplift, while nearby valleys register a settling or even a slight depression, depending on local geology and water movement. The satellite's sight is so precise that even the growth of a city or a dense forest can create distracting signals that Dr. Richards and her colleagues must filter from the data. Their findings are as methodical as they are tantalizing. Rather than a single spot, the uplift is spread in broad, gentle swells, certain valleys and hills gently stretching skyward year after year. To the unaided eye, nothing unusual would ever be noticed. But viewed from above by satellite and through Dr. Richards' careful analysis, a vast, slow-motion ballet is underway. Even after years of study, every new data batch brings surprises, an amount imperceptible to people yet monumental over centuries. Our land remembers, she often remarks. Chapter 4. Subduction Zone Forces at Work. One of the biggest players in Washington's geological saga, each year this colossal collision delivers immense pressure miles beneath our feet. Sometimes this tension is released suddenly, in the abrupt violence of a major earthquake. But more often, the process is painstakingly slow, accumulating strain deep underground. Imagine the scale. The Juan de Fuca Plate, a wedge of oceanic crust, is forced down into the mantle beneath Washington at a rate of a few centimeters per year. The same pace as your fingernails growing, this invisible struggle at the edge of the continent sends ripples of pressure upward, bulging the overlying land in response. NASA's satellites have captured the delicate results of this battle. In the most active zones of western Washington, the ground is measurably pushed upward by the steady advance of crustal material. Less a cataclysm, more a gentle rearrangement. Cities such as Seattle and Tacoma may not feel the strain directly, but their foundations are gradually being elevated on a geologic scale. Enough so that over generations, shorelines may shift, flood risks may evolve, and ecosystems may adapt. The state's very location makes it a front-row seat for the drama of subduction, its landscape forever shaped by the invisible, patient pressure of the Earth. Seismic risks are ever present, but so too is the steady, relentless breath of an uplifted world, sculpted over millennia. Chapter 5. Earth's Memory, Tracing Ancient Movements. Think of Washington's ground as a living memory, etched with tales of volcanoes erupting, ice sheets vanishing, and plates colliding. Every era leaves its fingerprint. Sometimes what the satellites pick up today has roots in the far-off past. Tens of thousands of years ago, enormous glaciers blanketed the Northwest, weighing down the landscape with hundreds of meters of ice. When the ice retreated, the crust began to rebound, a slow rise known as post-glacial rebound, which continues in subtle ways even now. In certain lowland regions, ground that was compressed by ancient glaciers is still springing back, inch by inch, century by century. NASA's INSAR data helps unravel these ancient histories. Subtle uplifts may trace the slow rebound of land once pressed down by glaciers thousands of years ago, or could be echoes of lava pushing beneath the surface from long-dormant volcanoes. Sometimes, underground rivers of molten rock nudge up the terrain, while sediments deposited eons ago are compacted and rearranged by ongoing geologic pressure. The result? Even the most present tense readings are steeped in stories that stretch across eons. With every scan, scientists draw closer to decoding how long ago upheavals still quietly move the land today. Even islands in the Puget Sound bear evidence of past glacial weight, their rocky cores gradually ascending. Each subtle uplift, measured in fractions of an inch across decades, is a time capsule of vanished landscapes. Chapter 6. Decoding Signals, Dr. Meyer Hoffman. Making sense of endlessly complex satellite data is both an art and a science, requiring the rigor and insight of someone like Dr. Meyer Hoffman, a remote sensing specialist and earth scientist. Dr. Hoffman parses overlapping signals, distinguishing whether a patch of Earth is rising due to tectonic activity, post-glacial rebound, or something altogether more subtle. Every dataset is awash in noise and competing influences. Trees may grow taller, rivers may change course, or new construction may alter reflectivity, all adding static to the tunes satellites try to play. Using algorithms and years of expertise, Dr. Hoffman teases out reliable patterns. Here, a measured rise is confirmed. There, a false signal is dismissed. Her work involves stacking images like deck cards, analyzing minute differences, and looking for harmony within chaos. As Washington's dynamic ground reveals itself in these vast, delicate mosaics, her interpretation shapes the very way we understand the story unfolding beneath our feet. What are we missing? What surprises may still be waiting, hidden in the data's intricate code? A sudden correlation between a rainfall event and a blip in ground elevation, or a patch of forested hillside gradually inflating over the years. Each is a puzzle piece, nudging scientists closer to understanding not just the causes of uplift, but the cadence and range of the planet's constant motion. Chapter 7. Volcanoes, Silent Architects. Washington's landscape is crowned by volcanic giants. While most days pass in tranquil silence, these volcanoes are anything but lifeless. The slow churning of magma far beneath the surface can subtly warp the land, even if no eruption ever follows. Satellite imagery has revealed that, periodically, the ground around these sleeping volcanoes swells outward. Such patterns often precede eruptions at more active volcanoes worldwide, as ascending magma makes room for itself by elevating the crust above. In Washington, uplift rates might spike near the crater of Mount St. Helens, or on the slopes of Mount Rainier, as underground forces stir. NASA's satellite tools have caught episodes where ground uplift clusters around volcanic peaks, sometimes hinting at magma rising, other times simply reflecting the complex plumbing deep in the crust. Dr. Hoffman notes that while large-scale eruptions are rare in a human lifetime, the processes that lead to those events are almost always accompanied by measurable, if faint, uplifts and shifts. Researchers monitor these signals, using them as a silent early warning system, a way to track the buildup of pressure before it breaches the surface. These episodes remind us that volcanoes don't always need to erupt to make their presence known. The gentle swelling and settling of their foundations is a dialogue between the deep earth and the satellites forever circling above. Chapter 8. Tectonic Stresses and Hidden Faults. Beyond volcanoes, Washington is laced with a web of faults, some mapped and monitored, others still obscure. These fractures can slip discreetly, making minute changes to the landscape. Satellite records sometimes reveal places where, over time, a patch of ground inches higher or settles lower. Sometimes this may be the signature of a hidden fault shifting, or the result of underground water movement or subtle ground readjustments. Consider the South Whidbey Island Fault, invisible from the surface yet responsible for past earthquakes. NASA's sensors pick up not only gradual trends, but also abrupt shifts, the faint signal of a slow slip event, a quake-like movement too gradual to feel, but powerful enough to nudge the surface. Sudden. The answers aren't always clear-cut. Yet by combining satellite imagery with geological surveys, researchers develop ever-sharper understandings of how these silent fractures constantly rearrange the form and height of the land we live on. Every crack, every buried fault, every minor release of stress leaves a faint mark, a legacy readable only by the most sensitive of instruments. Haunting. The ground, far from dead, reveals itself as always in motion, always susceptible to new forces acting beneath the surface. Chapter 9. Ground Truthing, Dr. Lucas Meyer. Enter Dr. Lucas Meyer, a field geologist devoted to translating digital abstractions into tangible realities. Armed with GPS units and geophysical instruments, Dr. Meyer heads out to measure firsthand the minuscule uplifts mapped by NASA's fleet. Each visit to a hillside, forest, or floodplain becomes an investigation. Does the ground here truly match the slow ascent recorded from orbit? In the dense green hush of a Pacific Northwest morning, Dr. Meyer and his team place their instruments, recording precise latitude, longitude, and elevation, often to within a few millimeters. Weeks or months later, they'll return to the same spot, striving to capture any shift, no matter how tiny. The reality of fieldwork is complex. Animal burrows, burrowing roots, shifting soil, and seasonal moisture all challenge the clarity of numbers beamed down from space. Yet these challenges are part of the process. Ground truthing, as it's called, ensures that what satellites see is not a technological mirage, but the real dynamic world. By anchoring satellite data in boots-on-the-ground measurements, Dr. Meyer and his team bridge two worlds, ensuring the unseen pulses of the land aren't simply digital phantoms. Where else might reality be quietly diverging from our assumptions? The pursuit of truth lies in the meeting of technology and human curiosity. Chapter 10. Water's role in lifting land. It's tempting to attribute ground movement only to dramatic tectonic and volcanic events. But water, in all its forms, can be a hidden sculptor. In places where the water table rises, aquifers recharge, or heavy rainfall soaks the layered soils, the pressure can push the ground upward ever so slightly. Even melting snow or glacial remnants haunting the Cascades play a role. Washington is famous for its wet climate. Clouds dragging across the winter skies, rivers filled to bursting, alpine snowfields feeding trickling rivulets all summer long. As water seeps underground, it fills pores in soils and rocks, generating outward pressure. In the springtime, when glacial melt accelerates, satellites routinely detect subtle bulges in the land, the result of hidden aquifers swelling with newfound moisture. The satellites, with their precision, sometimes register the swelling and shrinking caused by seasonal changes in water. Washington's famous wet winters and snow-capped mountains all feed into this subtle dance of compression, expansion, and uplift. In the Yakima Valley, for example, the replenishing or draining of aquifers during heavy irrigation years can be measured by the satellites as the Earth rises or sinks by fractions of an inch. Who knew that every storm, every melt, every change in water's path could gently nudge the entire landscape upward or downward? Our rainy season and snowpack aren't just weather. They're active, ongoing influences on the skeleton of the state itself. Chapter 11. Tracking the Cascades' epicenter. Of all terrain in Washington, the Cascades are perhaps the most carefully watched. Home to both active volcanoes and the site of powerful tectonic collisions, these mountains routinely flex, rise, and settle in response to deep Earth dynamics. Valleys and high peaks all participate in a slow, steady vertical choreography. Here, the land behaves like a living engine, constantly recalibrating, pressured from beneath. Major uplifts have been mapped above zones where earthquake strain accumulates, particularly along the east slopes of the range, where folds in the crust slowly ratchet upwards. INSAR images show, year after year, that no two periods are exactly the same. A bend here, a swell there, the mountains breathing in deep time. NASA's satellites have chronicled how, in some years, sections of the range tilt ever so lightly toward the sky, while in others, the chain seems to sink by minuscule amounts. A breathing cycle carried out over scales of years or even decades. The Cascade Range, far from static, is always recalibrating its shape, refusing to settle into a permanent form. These cycles can drive changes in river gradients, soil stability, and even where plants can grow. Over generations, such imperceptible changes can realign the course of entire streams or modify snowpack retention. Further evidence that geology is present in everything from forest ecology to city planning. Chapter 12. Human impact, shaping the signals. Though the ground's lifting can seem purely natural, human activity is often woven into the story. Dams built along rivers, the extraction of groundwater, new roads and buildings, all these can add or remove weight from the land, creating signals that satellites detect. In some cases, cities or farmlands have been observed rising slightly after water is reintroduced to parched aquifers, or sinking where resources are extracted. In the Columbia Basin, for instance, intensive irrigation projects and deep well pumping have at times caused measurable ground subsidence. which, when reversed by artificial recharge initiatives or wet years, leads to a rebound detected by NASA's satellites. Urban construction, too, can cause local compression of the Earth. Apartment blocks or office towers act like tiny mountains, pushing their way downward, while the removal of old industry or rewilded land can prompt areas to buoy upward. NASA's sensors, ever objective, make no distinction between human and natural causes. All are recorded, all become part of the mysterious pattern. Our choices about water, land, and development are literally rewriting the physical structure of our home. Chapter 13. Uplift and Earthquake Potential. One of the most dramatic implications of ground uplift relates to earthquakes. As pressure builds for years, decades, or even centuries along the subduction zone and within the faults of Washington, the land's slow ascent can be a silent prelude to something far more sudden and violent. The groundwork for major quakes is laid long before the first rumble is felt. Crustal plates lock, strain accumulates, and when release comes, the ground can shift inches or even feet in seconds. The slow, steady uplift detected by satellites is a symptom of this stored energy. By tracking where ground rises the fastest, or where uplift stalls abruptly, scientists hope to pinpoint areas of maximum risk. While satellites can't predict exactly when an earthquake will occur, they do provide early warning signs, mapping where strain is accumulating and where the ground seems poised for release. This information feeds into preparedness models, disaster response plans, and public safety efforts. In a state where geological drama is always close at hand, this ability to monitor warning signs from orbit represents a powerful tool for risk and preparedness. Researchers widely agree that understanding Washington's uplift is not just an academic pursuit. It is essential for safeguarding millions of lives, for designing earthquake-resistant infrastructure, and for building resilience in a dynamic world. Chapter 14. A living, changing landscape. Every measurement, every minuscule shift or rise in Washington's terrain is another chapter in a living story. The region is observed as never before. The slow uplift of ground, far from being a mere curiosity, becomes evidence, a daily, silent reminder that the land beneath us is always, steadily, in motion. In the forests, hikers walk paths that gently rise over decades with nobody the wiser. In coastal harbors, long piers may tilt fractionally toward the sky over a human lifetime. What else might be waiting in the data? What other patterns might emerge as NASA satellites continue their relentless, patient surveillance? These movements, too slight for us to sense but undeniable by satellite, reveal that the Earth is never truly still. And through this knowledge, we develop not just scientific understanding, but a greater humility and appreciation for the living planet beneath us. Chapter 15. The Unfolding Mystery Beneath Us. In the end, Washington's quiet, persistent lift is much more than a geological oddity. It's a whisper from the planet itself, a soft message broadcast across forests, fields, and cities alike. That message is one of endless change, of histories not yet fully read, and futures that refuse to be perfectly predicted. As we watch the ground rise, by millimeters and years, we're drawn into a mystery as vast as the sky and as deep as the Earth. The ground's motions are a living record of past cataclysms and unrevealed futures, a constant reminder that what seems solid can be in reality a transient stage set in perpetual flux. Philosophical. Our planet moves in slow, majestic rhythm, teaching us patience and awe. By listening, to satellites, to science, and to the ground itself, we stay attuned to the stories the Earth still wants to tell. The ground beneath you is alive with motion, lifting in ways that change history. Thanks to NASA's silent observers in the sky, the Earth's hidden rhythms are finally unveiled, reminding us that even quiet landscapes are full of possibility.